Okay, this video is about multiple step heat problems, and this is going to be question 4. Okay, so this time it's going to tell us that we are starting with 375 grams of steam at 133 degrees. So for step 1, we need to figure out where we are on the graph. So this is water, so we know that this flat spot, this is where we condense. That's at 100 degrees. Right? And we know that this flat spot over here is where we're going to freeze, and that's going to be 0 degrees. And the problem said that we start at 133 degrees. So we have to start above 100. So we're somewhere here. So where are we going to start? I don't know. It's either point A or point B. Either one is fine. I don't care which one you say. So let's say we're going to start at point B. That's where we're going to start. So that's our starting position. Then it says we're going to cool it down until it is room temperature. So cool it down. Room temperature is 25 degrees according to this problem, which is going to be somewhere, if this is 100, that's 050s here, halfway. So there's about 25 degrees. So we're going to be roughly at point F. You could say E or F. That's not the important point, but I would say, let's say you're about point F. Here's where we're going to end. Okay, so we've accomplished that. We know where we're going to start. We know where we're going to end. And now we have to figure out how many steps are hidden in this problem. And the answer is really 3. We've got the first step where we have to go down. We have to change our temperature. Then we've got the second step, where we have to come across and completely condense our steam into liquid. And then we have a third step when we're going to take our liquid water and we're going to cool it down. So we have 3 total steps. Cool the steam so that it can become a liquid. Then we're going to make it go from gas to a liquid. And then we're going to take our liquid and we're going to cool it down. Okay. Each one of these steps has to be done independently. They each have their own equation. So whenever we're on a slanted one, we are going to use Q equals MC delta T. And whenever we're on a straight part, a flat part, we're going to use Q equals MH. Okay, so let's take a look at this. So the first step, let's figure out how much heat we need over here. So that's going to be Q equals MC delta T. The problem tells us that we have 375 grams. And we need the specific heat. But there are 3 of them. There's one for ice, there's one for liquid, there's one for steam. How do you know which one to use? Well, here's where we boiled. We boil and condense. So if we're above that, we must be the gas. We must be the steam. So we're going to use our C for steam, which is 2.03. That's joules per gram degrees C. And then we need to know our ending temperature minus our beginning temperature. So this part of the graph, we didn't go all the way to 25, right? We did not. We can only take it one section at a time. So we're going to go from 133 down to where the section ends, and the section ends at 100 degrees. So this is going to be 100 degrees is my final temperature, minus my beginning temperature of 133 degrees. And if you multiply all this stuff through, you're going to find out that this part is 25,100 joules, or 25.1 kilojoules. And you're also going to know that I just lied to you, because when you subtract 100 minus 133, you're going to get a negative number. Why are we getting a negative number? And the answer is because we are cooling this material down. Okay, so this is going to be a negative, or in the negative. So we get negative 25.1. Okay, so that's section 1. Now we have to do a completely new problem, because now we're going to go from the point at which the steam started to become a liquid till it is completely a liquid. And that's a flat spot. So that flat spot's going to need Q equals M delta H. So our mass is the same, it's 375 grams. And now we have two delta H's. There's a delta H of fusion and the delta H of vaporization. So we vaporize, that's the opposite of condensing. So we're gonna use our vaporization here, where it's essentially boiling, and we're gonna call that 2260 joules per gram. But here we have to do one of two things. We can either right now say, wait a minute, 2260 is positive, but I'm cooling it, I need it to be negative. Or you can just wait till the end and change the sign. It's up to you. I'm gonna do it now. I'm gonna say, hey, we are cooling, so that thing is a negative 2260. And when you multiply those two numbers together, you are gonna get yourself 847,500 joules, like that, which I'm gonna report as 847 kilojoules. And shoot, I already messed up. It's gotta be negative, right? Because we are cooling it. We are cooling it. Okay, now this board's getting kind of crowded. So what I'm gonna do is I'm gonna erase some things and hold on to some numbers. So I'm gonna say that we're gonna do this problem in 3 steps. Step 1, we got 25.1 kilojoules. In step 2, we got 847 kilojoules, like so. And now we have to do the third spot, the third step in this whole process. So let's clear ourselves some room here. So now what we're gonna do is we're gonna go from here, where we are completely liquid, and we're gonna cool that liquid down to the end. This is a slanted part of the graph, so we're gonna go back to our Q equals MC delta T. We've still got 375 grams. We need the C. Oh shoot, we have 3 C's. Are we ice? No, ice is below that flat spot there. Are we a liquid? Yes, we are. We're a liquid right here. So my C this time is 4.18 joules per gram degree C. And now I need my temperature change. So I'm going to do my ending temperature minus my beginning temperature. And we were told we're going to end at room temperature, which is 25. And we started up here at 100. That's where we started this section. We didn't start at 133 for that section. That was a different problem. So we have to start, where did we start the section? And we started it at 100 degrees. Okay. If you multiply these 3 numbers together, you are going to get yourself 117.600 joules. And again, 25 minus 100 is negative, so this is a negative number, which I'm just gonna say is 118 kilojoules. Okay, that was our third step, but to get our total heat, we need to bring it over here and say the third step was negative 118. And if you add all these together to get the total process, you're going to get negative 990 kilojoules. And that is the answer for that thing. So as long as you are close, you may have rounded differently than I did at some point during this process, that's fine. As long as you're close to 990 kilojoules, I like it. You have to show your work. You can't just mysteriously show up with these 3 numbers and say, here's my answer. Like, I need to see some piece of this. Now, do you have to show every minute detail? No. If you were just to say 375 times 4.18 times negative 75, that's fine. Like, I can read math, I can follow you, but I need to be able to see like what's going on during the process, and that's it. Okay, good luck. You're gonna finish up questions 5 through 9, and you're gonna use this process the entire time. Break it into pieces, figure out how many pieces you need, and then solve each piece individually and add them all up. Good luck.